MCQ 23 is very similar to MCQ 22, but it's a little bit more cryptic. So let's just go through each of them to see what are kind of elucidation that we can actually get out. So for the first one, treated with sodium boron tetrahydride. Now this is a very weak reducing agent that really only have the capability to reduce a very small subset of function group, namely aldehydes and or ketones. Alright, you can see that through this reduction, it actually did work because the Y+2 here shows that a reduction did happen. So in the case here, just for visual, if let's say I have an aldehyde, post-reduction, it will become a primary alcohol. So again, where did the extra hydrogen came from? These are the two hydrogen that came out, so it becomes a Y+2. But if let's say we're dealing with a ketone, post-reduction, it becomes a secondary alcohol. The two additional hydrogen again came from here. So I kind of know I'm dealing with either a ketone or that of an aldehyde. Not very, very informative. So for the second case here, it can give a compound with a Z+1. Now I think that this is the most important point over here. Anything that causes an increase in oxygen is usually going to be for the case of oxidation. So if let's say I started out with an aldehyde, and if I were to go for an oxidation event, now whether is it with acidified KMnO4 or acidified potassium dichromate, I'll be obtaining a carboxylic acid. Do see that there's an increment in one oxygen. But if let's say we hang on with the original ketone idea here, ketone is done for. It cannot go for any form of oxidation. So this kind of anchor down towards that we probably were looking at an aldehyde for the function group that's found in T. Now in option 3, we go down to talk about its reaction with 2,4-DMPH. So 2,4-DMPH really just tests for the presence of carbonyl compound. So this very much aligned with our idea that we might very likely be dealing with an aldehyde structure. And the last one here, which is the inability to react with sodium metal, means that we're looking at the absence of acidic group, in this case here aliphatic alcohols, absence of phenols, as well as the absence of carboxylic acid. So C is going to be out here based off the case for the fourth point, because it cannot react with sodium metal. And A and B, just based off the blue result, is going to be correct, and D also is going to be correct. But we have already isolated based off the pink result that it should really be exclusively an aldehyde to give us the additional one more oxygen after the oxidation event. So it's going to be for the case of A. I'll then say that A is the correct answer. B is going to be out. It cannot be a ketone functional group. So D mentioned that there is an aldehyde functional group. Right, now that we do agree, and there's also a ketone functional group. Now, why this is not going to be okay is because if we're going to talk about having both an aldehyde and a ketone function group, when T were to undergo a reduction process, again, T has the original CXHYOZ portion here. Since there's two carbonyl groups for the case of my reduction, the reduced T will have give the formula of a CXHY plus 2. This plus is for the aldehyde, and another plus 2 for the ketone and OZ to give us a HY plus 4 rather than the plus 2 that the question have mentioned. So in this case here, the correct answer for this question is